Not easy for me, I mean generally easy for most people. Not my type of easy. So, this is what? 1-7 inequalities. Inequalities basically follow the same rules as equations. Whatever you do to the one side, you have to do the exact same thing to the other. The reasoning is a little bit different. You're not trying to keep the scale balanced. You're trying to keep the scale unbalanced exactly the same way. Because inequalities are one is bigger than the other one is smaller than the other. I guess symbolism is the best thing. We're going to have to do interval notation. This will be something new for most of you, and I require you to use this the rest of the semester. If I see a less than or greater than sign, I get very upset, because that's old notation. For instance, old notation, x is greater than or equal to 4. This means x has to be 4 or larger. 4, 5, 6, 7, 4.1. It has to be something bigger than 4, but it can't be 3, it can't be negative. That's pretty much what we're talking about. If you graph this on a number line, you put a 0 here, you put a 4 here. What shape were you taught to put on or above the 4? I always put mine above because pencil, you try to draw the line on the graph and it just buries itself in the number line itself. So I always put mine above. What shape would you put above 4?
So,
what kind of circle? Closed circle, shaded circle. So you put the closed circle there, that represents the equals, right? Which way would you go with the solution set? To the right. Now here's a neat little fact. The end of this symbol, see this arrow, tip of the arrow, is exactly the same as the inequality. That's where inequalities come from. The symbol for inequality is actually from the arrow on a number line graph. The x has to come first for that to work. So if it's 4 is less than or equal to x, you have to flip it around so it's x is greater than or equal to 4. Alright, that's all old school stuff. New school, you replace the closed circle with a bracket. The arrow goes in the same direction. But that's not interval notation. That's just one of the replacements that we're going to do. So this x is greater than or equal to 4 is represented by a bracket. The number that it starts at, in this case, 4, and it goes off to the largest number it can contain, which is infinity. That's what the arrow represents. It's going off to infinity. Now I need to stop this somehow, but infinity never ever, well, stops. So I can't use a bracket, so what I'm going to use is a parentheses. So basically this says from 4 to infinity is our solution set. It's much more concise than saying x is greater than or equal to 4. It tells you exactly where it starts, and it tells you exactly where it's going to. Does that make sense? It's a better notation, trust me. Alright, how about x is less than negative 3? Now, we're going to graph that on a number line. You put a 0 here, negative 3 goes to the left someplace. What kind of shape do you put above negative 3? An open circle, because you cannot include the value of negative 3, but it can be anything that is less than it. And this arrow pretty much tells you what the arrow end should look like, so it better be going to the left. So you get this shape, and there's your less than symbol. Alright, that's great. So what is the next number that is less than negative 3? Really, the next number is negative 4. Remember the first day of class we talked about the real number system, and I yelled at people for saying 2, 5, 7, 13, because the real number system is, there's a lot more to it. So when I say what's the next number to negative 3, the best thing you could say is negative 3.0000000000000, 100 zeros and a 1. It's really, really close, but that's why this one is a bad notation for a lot of people because they think it's, oh, you can't be -3, the next one is -4. There's an infinite number of numbers between those two, so you've got to be careful. This one is much easier. It starts at 4. There is no guesswork about that. Starting less than -3, that's a little bit more ambiguous, but that's just theoretical stuff. So how do I write this one? Now, interval notation is really important. Smallest number has to go first. Largest number has to go second. What's the smallest number this ever gets to? Negative infinity. And what's the largest number it ever gets to? Working your way up, working your way up. Where do I have to stop? -3. Now, it's an open circle, so we're going to give him a parentheses. So if you're going to do this with symbols on the number line, it would be parentheses that way. All right, so this is the interval notation for all the numbers 4 and greater. This is the interval notations for everything less than -3. So far, so good. You can't contain infinity. See, this 4 says it's exactly equal to 4. How can you be exactly equal to infinity? Because there's always one more. There's always one more. All right, now what's wrong with this notation? Well, one small thing. If I do this, I better start it up here. -2 is less than or equal to x is less than 4. This is called a double inequality. It is shorthand notation for something totally different. Shorthand notation for x is greater than or equal to -2 and x is less than 4. It's a split of, it's actually a combination of two inequalities. But writing it this way takes way too long. And basically writing it this way means the exact same thing. It's all the numbers bigger than -2 and all the numbers smaller than 4. Key word there is and. It means you have to, both conditions have to exist. Another language for this, if we do it on a number line, here's -2, here's 0, here's 4. Goes off forever and ever. What kind of symbol do you put above -2? Closed circle. So you put a closed circle here on -2. And the arrow would go to the right. We're looking at this one here now. So he's going to the right. What kind of circle on 4? Open circle. And it would go to the left. So does this mean my solution set is all real numbers? The answer is, it better not be, because why else write it? If it was all real numbers, I would just say all real numbers. So the trick here is, what does it mean to be and? I'm going to the store and the bank. If I'm going to tell the truth, I have to do both of them. So the only solution is where both the green lines are. So if I look to the left of -2, there's only one line. And if I look to the right of 4, there's only one line. So the solution is going to start here at 2, -2, and it's going to end at 4. So what's a better language for all of these numbers in here? Where are they? How would you describe those numbers? In between. So this notation up here really reads x is between -2 and 4 and equal -2. That equal sign throws off the language a little bit. If I got rid of the equal sign, it would be perfectly x is between -2 and 4. So when you read this, don't read it as -2 is less than or equal to x is less than 4, because that tells you absolutely nothing. But if you say x is between -2 and 4, you can kind of get a mental image where it falls. All right. Now the interval notation literally looks like that. Bracket for the -2, comma, where does it end? 4. That's much more concise. Starts at -2, ends at 4. So, what is this? What does that represent? Depends on what I'm talking about. Are you assuming that I'm talking about an inequality, an interval notation? What else could it be? A what? A point on the graph. So this one becomes kind of ambiguous. if I just wrote it in the paper or something, you could either look at this as a point or a interval. These are a little bit more clear because they have brackets or infinities, and that kind of clears it up. But if it's an in-between notation, it gets kind of, well, do I plot it, or is this starting at 3 and ending at 5? The best way to denote it then is to put x here. That tells you what number line you're dealing with. This is the x number line. And then you put this little symbol. This is called the element symbol. And what the element symbol does is it says, this is an x value, and it is an interval notation. So all the numbers between 3 and 5. So this is the same thing as 3 is less than x is less than 5. So if you get into the parentheses and it becomes a little ambiguous, if you're talking about a point or an interval, you might want to put this symbolism in there. It'll tell you it's an interval. If you just leave it like that, if it's understood that it's an interval, that's great, but if people can get confused, it's better to put the x element. And you can do that with all of these. It'll be perfectly fine.
Like when you do the little u thing, is that when it's not in between those two numbers?
Right. We'll get to that.
Okay.
Union. This, by the way, and actually has this symbol, which is intersection.
No, that makes sense.
Union looks like a U. Union.
I don't get like when they go up and down. Because one of them is the other way.
Yeah. This one means put them all together, like you're getting married. So you take all your stuff from your house and your husband's house and you put them all together, union. This one means you're going to get rid of the stuff that's in common. So if you get married, you get rid of the stuff that you have double of. So if you have 2 beds, then you get rid of 1 bed. In a weird way. And then if you get divorced, now, I don't have a symbol for that. I guess this would fit. No elements. What did you say? Half. Yeah, that's a good one too. Half. All right, so that's interval notation. We'll get to I don't use intersection that often. The book will talk about it, but you really don't use it. It's better to say and, they're in common, and you just write the interval notation. Unions come in handy for other things. But we'll be talking about that in a second. All right, so that's the symbolism we're going to work with. And now we need to solve equations. Just make up one. I have no idea what the answer is, so don't ask me. 1 minus x plus 3 over 4 is greater than equal to 2/3 plus 3x minus 1 over 2. Since I made it up, the answer is going to come out horrible. Well, if it comes out nice, I'm a miracle worker, but it should come out horrible. How do you solve this inequality? Well, first of all, think of it like an equation, but do not change that symbol. Keep that symbol there all the way through the problem. You cannot change it to equals, because if you change it to equals and you forget to change it back, you're going to get the wrong answer. All right, so what would be your first step? Better than that. Close, though. 2 will get rid of one of them. It won't get rid of all of them. God.
2 and 3.
2 and 3. That brings you up to 6. You always know the answer, but you sit there and just stare at me.
8.
Can't you do 3 over 2?
No.
And you can't switch them?
No.
Why?
Please don't. Multiply by the common denominator,
Didn't you
12.
say
which is, who said that?
Hey.
Oh, I thought you said 2. That's why I said no, not 2. You mean 4.
That's the way I did it, not the way.
Didn't you hear me back? I said 2.
No.
Oh, shoot, you don't listen to me. I didn't hear you then. So multiply everybody by. Well, I was wondering why no one was saying it. Oh well. So if you multiply through by 12, you get 12 minus 3. The quantity x plus 3, leave that in parentheses, is greater than or equal to 8. 3 goes into that 4. 4 times 2 is 8. Plus 6 minus 3x minus 1. Shrink this down. Alright, get rid of parentheses and all that fun stuff. So this is 12 minus 3x minus 9 is greater than or equal to 8 plus 18x minus 6. Yeah, she should be able to do it that quickly. But don't do it so quick that you make silly little mistakes, like, forgetting that this is a negative and multiplying and get a positive one there or something silly. Combine like terms. Hope I did that right. Oh, don't assume I do my calculations right. I've warned you all that I'm not good with calculations. Make sure that I'm doing every step perfect, because I will make a mistake because I'm not even thinking about it. Next up. Highly suggest next step. This is an inequality. It is really, really important to keep the variable positive. If you make it negative, we're going to have to come up with another trick, and I'll show you that in a bit, but I haven't talked about it yet. So let's keep the variable positive. So which one should I move? The 3x. So add the 3x to that side, and you get 3 is greater than or equal to 21x plus 2. All right, then what? Subtract 2 across, and you get 1 is greater than or equal to 21x. Divide both sides by 21. So you get 1 over 21 is greater than or equal to x. But I just warned you from before, you really want that variable first. So what can I do to this inequality? Pick it up. Flip it. Now be careful, when you flip it, he has to flip too. The inequality has to flip. If 121 is bigger than x, then x must be smaller than 121st. So less than or equal to 121st. Yay! Except if you leave this on a test, you lose a point. Because I already warned you, don't want to see old notation. I want to see interval notation. So if you don't know what the interval notation is just by looking at it, the best thing to do is go off to the side, just draw a little number line graph. Here's 121st, here's 0. What shape do I put on 121? Closed circle. Which way is it pointing? To the left. As long as your inequality is lined up with the x first, that will point in the direction of the arrow, because that's what the arrow is. All right, how do I write that in interval notation? Where is it coming from? Negative infinity. Where is it going to? And what shape do I give it at the end? Bracket, because it is equal. Ta-da, done. It's not that bad. So this little section goes over all the linear equations and some of the other stuff that we've been doing earlier, but now it's just with inequalities. So what happens if you can't make the variable positive in one step? Well, you could do a couple things. You could shift it all over to the other side and force it to be positive, or you can think of this little fact. If 2, well actually it's not an if, 2 is less than 5, true or false? Oh, true. What happens if I multiply both sides by -1? Then I get -2 and -5. What's the relationship between those two?
-2 is greater than.
-2 is greater than. So the trick is, if you multiply or divide both sides by a negative, doesn't have to be -1, just a negative, the inequality has to flip. The inequality has to flip. So if we did decide to choose to move the 18 across, we would have negative 18x is greater than or equal to, and then when we divide it, it would switch back to our less than or equal that's down here.
Everything would have to multiply by negative.
Both sides, yeah. Entire sides have to be multiplied by a negative. You can't just do partials. It has to be the whole thing. What's this? That's boring. That's boring. Should we do that one? Double inequality. What if we have -3 is less than 2 minus 3x over 4 is less than 10. Excuse me. there's two ways of doing this. Way number one, separate it by the definition, if you want. I'll show you the separation, and then I'll show you the shortcut and why it actually works. So the first part is you can only look at the first two terms. So this says that negative 3 is less than 2 minus 3x over 4. Negative 3 is less than 2 minus 3x over 4. And is the key word. What's the second inequality? Now we're just going to do a little mental math. We're going to look at these two equations and figure out how to solve both of them without actually solving them. What would be your first step on the left one? Multiply by 4. What would be your first step on the right one? Same thing, multiply by 4. After the 4 is gone, you would subtract both sides by 2. And in this one, you would also subtract by 2. And then eventually you divide by negative 3. So whatever you do to the left-hand one, you're doing the exact same thing to the right-hand equation to solve this equation. So the trick is, let's just do it to the whole thing. So take negative 3 less than 2 minus 3x over 4 less than 10. The first step of solving both of those equations was multiply everybody by 4. So you multiply the left, the middle, and the right by 4. This trick only works with double inequalities. It's not a legal notation in math because equalities, there should only be one of them. This is, remember, shortcut notation. But whatever we did to those two, we're doing to all three pieces here. So once you divide them all by 4, multiply them all by 4, the left-hand side becomes negative 12 is less than, what happens to the middle term? The 4's go away and you're left with 2 minus 3x is less than 40. Hey. So no more fractions, and we're solving the equation in one fell swoop rather than doing it separate times. All right, what would be the next step of solving this blue equation? Subtract everything by 2. And that means left, right, and middle. Equations have a left and a right. This thing has a left, middle, and a right, so you can do it to every piece. Left-hand side becomes negative 14 is less than negative 3x is less than 38. Ooh, this is not going to be pretty. Oh, life goes on. What would be the next step? Divide by negative 3. Once you say that, bells and whistles need to go off in your head. You're dealing with an inequality, and you just divided by a negative. Both of these inequalities are going to have to flip. So divide everything by negative 3. This side becomes positive 14/3. This symbol becomes greater than. That's just x. The other symbol becomes greater than. This side becomes negative 38/3. Ugh. Never promised nice. That's illegal notation. That's worse than a double inequality. That's a double inequality that's written incorrectly. Double inequalities always have to be less than less than. It always has to start with the smallest number, and it always has to work its way to the biggest number. So I need to pick up this whole thing, flip it. Inequalities included. So when I flip it, negative 38/3 comes way over here. The symbol that was next to it is this one. He has to flip in place. So when he flips, he's going to come back to this negative 38/3 as less than. X is in the middle. He doesn't go anywhere. That inequality is going to flip. It also becomes less than. And then on the far left becomes the far right. 14/3. So how do you read that in English? Do you start off saying negative 38/3 is less than x is less than 14/3? Does that make any sense to anybody? No. What's the English word for it? Begins with a B. It's between. X is between negative 38/3 and 14/3. Gives you a better visual image. Is that how I want you to write the answer?
Yeah.
No. First symbol I need to write is, for less than at least, smallest number this can be.
Negative on infinity.
Negative 38 thirds.
Oh yeah, but
It's between. If it wasn't between, it would, infinity, but it's between. It can't go to infinity. What symbol do I put next to it? Parentheses, because it's not equals to, comma, biggest number? You'll never write X in here. This is just numbers. So it's smallest number, comma, biggest number.
Negative
14 thirds. It starts here, it stops there. It can only be between those two numbers. If you're infinity, you're not between any two numbers. So the next one is what? 14 thirds? This is that ambiguous one. If I didn't know this was an interval, you might want to put this in front. X is an element of that set. Or an element on that interval. Go for it. Here, when you're solving this equation, inequality, 2 is the first thing you need to move because it's not next to the x.
Okay, I got you.
It's a positive 2, so you're going to subtract it. Where else would it come
I didn't know.
from? Additive inverses. Additive inverses. That's not that bad, is it? Practice.
That negative 1, you said to multiply.
If you multiply by a negative, you have to put them in inequality.
Yeah. But that 14 over 13, you really should
It's
be
what?
negative 14.
It's negative 14 over negative 3.
Oh, you could.
Well, yeah. But then it becomes positive, then you multiply by a negative 1.
But I divided by negative 3 all the way across, so I have to take the inequalities and flip them. It doesn't matter if it turns out to be positive or it turns out to be negative. It matters that I divided by a negative.
Yeah, but where's the negative 1 go?
It's negative 1 times 3.
So
It's not necessarily negative that does it. It's not the 1 that does it. It's actually the negative part of it that changes signs. 1 is just an identity.
It's not 1, it's negative.
But 3 is negative. You divide
Yeah,
by
but
it.
it's already negative.
No. If you divide by a negative, to get through your inequality, if you divide by a negative, the inequalities have to flip.
So you're not actually multiplying by 1. I mean, multiplying by negative 1, right? You understand?
I know what you're saying. You're looking back here and it has to be negative 1, but it doesn't have to be negative 1. I could have multiplied both sides by negative 10.
Well, yeah, I understand that. It's not the 1 or 2 or 3 or
Okay,
4.
wait,
It's
wait.
the negative.
But if you,
Why did it turn positive?
because it's negative over a negative.
Well, yeah, that was before you multiplied out by negative.
Okay. Hold on. Let me see if I can get this out. How would you solve this?
Add 2. Just kidding. I don't know.
Oh, come on. It's a simple linear
Minus
equation.
4, minus 4.
Subtract 4 from both sides, right? So this becomes negative 3x is equal to negative 14. What would be your next step?
Negative 3.
Divide by negative 3,
And it was positive.
and it becomes positive. I don't understand what your question is then.
Well, you said that you had to multiply everything by negative 1
I'm-
because you're divided by a negative. Or you have a negative in your.
If you division and multiplication are technically the same operation. Do you want me to prove it?
No.
Yes, you do. So, if you have negative 14 over negative 3, that's the same thing as negative 14 times negative 1/3. So this is written as division. This one's written as multiplication. So if you divide by a negative, that's the same thing as multiplying by a negative. If you divide or multiply by a negative, flip the signs.
But you don't actually have to do it. Right? But yeah.
Whatever
I just
happens,
don't do it, okay? Yeah.
whatever happens after that is irrelevant. If you divide or multiply by a negative, flip the signs.
Yeah,
I don't
flip
care-
Signs, but don't change.
Don't change your calculations.
Don't change the numbers. Don't change the numbers itself.
No, do your calculation. Whatever this turns out to be, it's going to turn out to be. But if you do put this negative 3, before you even think about the calculations, once you put that negative 3 down there, those signs have to flip. Then you can think about, oh, negative 14 over negative 3 is positive. And positive 38 over negative 3 is negative. But that's irrelevant to the signs, less than greater. I think you're thinking because it turned positive that you don't have to do anything. That's irrelevant.
Well, no, alright, yeah, okay. You make it.
Think about it clearer and then break down. You know, formula. What's worse than that? Oh, this is worse. Absolute value equation. Oh, not equations. Oh, are you too tall for her?
No, I realized I was just sitting there right in front of them. And she could see.
I was just sat right there and block everybody's view. No one sat behind me. No, actually, I used to sit in the corner over there, so no one was behind me, period. Helps me. Inequalities, not equations. Absolute value inequalities. We already did absolute value equations. The one thing I do not put on the test is absolute value equations. I always put inequalities because it's got a slight trickier part to it. Equations are actually easy. Inequalities, for some reason, people mess them up. So, for example, if I have the absolute value of 2x plus 3 is greater than 10, and I want to solve this absolute value inequality, the steps for solving it are exactly the same as solving an absolute value equation. You split it into two pieces, the positive part and the negative part. So you treat 2x plus 3 as a positive number, and then you turn around and treat 2x plus 3 as a negative number. There are x's that will make it positive, and there are x's that will make it negative. When 2x plus 3 is positive, how does it come out? It comes out as itself. It doesn't change at all. So it becomes 2x plus 3, and it's going to be greater than 10. When the inside is negative, how does it come out? It's opposite. It's opposite. So it would be negative 2x minus 3 is greater than 10. So one, you just leave it exactly the same as it is, and then you take the insides and change all of their signs. Multiply the insides by negative 1. Leave the other side the same. How do you solve the first one? Oh, minus 3. I was going to sleep there for a second. So this is 2x is greater than 7. Divide by 2 and you get x is greater than 7 halves. Please don't write 3 1/2. That's for cooking. 7 halves. Alright, this one over here, how do you solve it? Add 3, you get negative 2x is greater than 13. Divide by negative 2. And you get x is less than negative 13 halves. Alright. So what's my answer? Do I just choose all the numbers bigger than 7 halves and smaller than negative 13 halves? Do I choose the numbers between negative 13 halves and 7 halves? Or do I choose all real numbers? Those are your options. So how do you narrow it down to the right solution? One trick to use, which is guaranteed to work all the time, so therefore I highly suggest you learn it so you don't make any silly mistakes. Put the numbers on a number line. And this is called a number line test. We're going to test the intervals on this number line with the original equation, see which ones work. Why not? So pick a number less than negative 13 halves. 5. What is 13 halves equal to? Decimally. 6.5, right? This is negative 6.5. What's smaller than negative 6.5?
7.
Negative 7, negative 8, negative 1,000,000 if you really want to go that far. But negative 7 should work. Go back to the original equation. 2 times negative 7. Careful. Negative 14. Negative 14 plus 3. Negative 11. Absolute value of negative 11. Is 11 bigger than 10? Yeah. So you put a big check here. Works perfectly fine. Good. Checks are good. All right. Pick a number between negative 13 halves and positive 7 halves. Easiest number. Easier is 0. Put in 0. 2 times 0, 0. 0 plus 3, 3. 3 is absolute value, 3. 3 bigger than 10? Heck no. So we can't choose any of the numbers on that interval. Pick a number bigger than 7 halves. By the way, it's 3.5. 4. 2 times 4? 8 plus 3? 11. And 11 is definitely bigger than 10. It works there. So we're talking about all the numbers less than negative 13 halves and all the numbers bigger than 7 halves. So how do I write that? Interval notation. So first off, it's less than, so or greater than. So it's open circles. So it's going to be an open circle here, and we want to go that way. And it's going to be an open circle here, and we want to go that way. We don't want to include anything in between. So how do I write the first interval from here to negative 13 halves?
Negative infinity.
Negative infinity has to have a parentheses, comma.
13 halves. Negative 13
You just don't like saying negative, do you? Negative 13 halves. Symbol,
halves.
parentheses. Starting up again at?
Negative 13 halves.
Got to skip all this, and it starts up again at?
7 halves.
7 halves. And it goes off to? Infinity because of that arrow. Now the symbol, there has to be something in here to connect them. And that's when you use your union thing. So you say union. Now there's no mistake in that. That's interval notation, so you don't need that X element symbol. But that's how you solve a absolute value equation. Now there are shortcuts to this, but I don't teach shortcuts. If you want to figure it out on your own. Because if I tell you what the shortcuts is, and you forget what the shortcuts are, and you don't remember how to do it the long way, you're going to not how to remember to do it at all. So I don't teach shortcuts. That number line trick will work every single time. So, your turn. We'll see what you remember. For example, the absolute value of 4 minus 5x is less than or equal to 21. Solve me this equation. I'll give you 2 minutes. Which is 1 minute longer than it should take, right? Alright, let me run through it really quickly. Positive, negative. I highly suggest you use this little notation to remind yourself that there's 2 parts to this thing, rather than just the one. If it's positive, it comes out as 4 minus 5x is less than or equal to 21. Nothing changes, the absolute values just drop. When you treat 4 minus 5x as a negative number, how's it come out? Negative 4 plus 5x is less than or equal to 21. Opposite. You change all the signs. Just not the other side. Not the other side. So it's negative 4x plus 5x. Negative 4 plus 5x is less than or equal to 21. All right, what's your first step in solving the left-hand equation? Subtract 4 from both sides. So this becomes negative 5x is less than or equal to 17? 17. And then divide both sides by negative 5.
That ain't supposed to be a plus 5? What? No, I'm talking about the 5x.
I know, you're talking about here, right?
No, I'm talking about the first one.
Here? Why would it be plus?
Because it's a positive sign, right?
It's negative.
Yeah, but you're making it all positive.
I'm leaving it as a positive number. I'm not changing the sign.
Okay.
You're thinking, oh, I know you're thinking. You're going, oh, it's absolute value. Change it to plus.
I got that right. I got that wrong and that right.
So the 5s are going to cancel, and you get x is greater than and or equal to negative 17 fifths. As the inequality has to flip, it is that negative division. Over here, what's the first step? Add 4 to both sides. You get 5x is less than or equal to 25. Therefore, x is less than or equal to 5. Okay. So, How do you get to your final answer? I highly suggest, number line, here's negative 17/5. Here's 5. Pick numbers on each interval. Something less than negative 17/5, something between the two of them, something bigger than 5. What's smaller than 17/5? Negative 17/5. Negative 4. So plug negative 4 back in. 5 times negative 4 is negative 20, but there's a minus sign there, so that's 20. 24's absolute value is 24. Smaller than 21? No. So you get a big X there. Pick a number bigger than 5. 6. Negative 5 times 6 is negative 30. 4 minus 30 is negative 26. My brain just went out. Absolute value negative 26 is 26. Is 26 smaller than 21? Nope. So where's the answer? In between. So double inequality, it would be negative 17/5 is less than or equal to x is less than or equal to 5. That would be the double inequality notation. Is that what I'm looking for? Heck no. I'm looking for bracket starts at negative 17/5, comma, ends at 5, bracket. And there is a solution. Interval notation. It is between negative 17/5 and 5, inclusively is the fancy word. Inclusively.